Hi everyone, this is Shivam. Welcome back to the Kubernetes for Beginners series. In previous video, we understood where containers actually run. So container runs inside a pod and pod runs on a node. But now comes the most important question. When a real user opens the browser, how does the request reaches your application running on Kubernetes? Because user won't know what are pods, they don't know about nodes, and they don't know about IP addresses. They just expect the app to load. So in this video, we will understand how users reach your Kubernetes app using services. But before we do that, let's recap what we discussed in our last video. So container runs on pod and pods runs on node. Let's understand the problem first. Pods in Kubernetes are temporary. A pod can crash, a pod can restart, a pod can get a new IP address. So today, your app might be running on one IP, tomorrow a completely different IP. Now imagine giving this IP address to users. Every time the pod restarts, your app would break. So Kubernetes needs something stable, something that does not change. And that stable layer is called services. A Kubernetes service is a stable entry point to your application. It provides a stable IP address, a stable DNS name, a single way to access your app. Even if pod changes, the service does not. Users never talk to pods directly. Instead, users talk to the service, and the service forwards the traffic to the correct pod. This is the single idea that solves the entire problem. Think of a service like a reception desk. Users come to the reception. They don't care which employee is available. The receptionist forwards the request to someone who is free. If one employee leaves, another takes over. But the reception desk never changes. Similarly, in Kubernetes, pods come and go, while service stays. Now the question is, how does a service know which pods belong to it? And the answer is labels. Pods have labels and services have selectors. So like we can see here, our pod has a label app equal to my app. The service uses the same label as a selector. Any pod with that label automatically becomes part of that service. If new pod comes up with the same label, the service automatically includes it. No manual configuration needed. This is how Kubernetes dynamically connects traffic to pods. Don't worry much about the pods, how they get connected to services. We will do a deep dive into this in the demo section. Now, one important thing to consider here is that in production environment, your application always runs on multiple pods. All pods have the same label. The service sits in front of them. User sends the traffic. Service receives traffic. Service distributes traffic across pods. And you automatically get basic load balancing. Right now, don't worry about who creates those multiple pods. We will cover that in the next video. For now, just understand that services can route traffic to many pods. Kubernetes provides different types of services. From a beginner's perspective, remember only these three. First is the ClusterIP, which is accessible inside the cluster. Second type of service is a NodePort service, accessible via node IP and port. And the third one is the load balancer, accessible from the internet. You don't need to memorize details yet. Just remember, services control how traffic reaches your application. Now let's summarize what we have discussed till now. Pods are temporary, pod IP changes, but services are stable. Services IP do not change. Users never talk directly to pods. Instead, user always talks to a service. That's the core idea. Now let's head to the demo section and we'll see how pods and services work together. Now let's understand services by using our local cluster here. So this is the demo pod which we created earlier for our last video. This pod has an IP address, but remember, pod IPs are temporary. Now let's try to create the first type of service, which is ClusterIP. I am using imperative command to create the service. The service type, as you can see here, is ClusterIP, and the service itself will run on port 80. Now let's hit enter. Our service was created. Let's check our service. And we can see here that our service, which is called demo pod, has been created. This is the service IP address. which is running on port 80, and you see here this selector. This selector points to this demo pod. Let's verify that. Let's do a describe on our pod. And what we can see here, the name of the pod is demo pod, and this pod is having a label of run equal to demo pod, what we exactly have here in the service. So we can clearly see that our pod is now connected to the service. ClusterIP is an internal service. So what internal means here is that this service cannot be accessed via browser or from the internet. Now let's delete the ClusterIP service and we'll explore the second type of service, which is NodePort. Okay, our service got deleted. We can see here there is no service named demo pod. Let's try to create a NodePort service. So I have already written this NodePort configuration. This configuration might seem overwhelmed to you guys, but don't worry, you don't have to memorize this file. This file can be easily accessed via Kubernetes official document. Let me show it to you. So you go to Google and type Kubernetes, and you need to head to this kubernetes.io website. Search for NodePort service and go to this service section and click on this NodePort, and see here you have this entire YAML configuration for NodePort service. Now let's come back to our configuration. We can see here the type of service is NodePort. The service name is demo pod, and it has a label which is called demo pod, and we can see the selector here as demo pod, which is actually getting connected to our pod. The service itself is running on port 30001, and this target port specifies to the container port of our pod. Now let's save this file and create our service. It says service has been created. Let's check that. We can see our service demo pod has been created, and it's of type NodePort, and it is running on port 30001, and it is binded to our pod run equal to demo pod. One important thing to note here is that NodePort runs on a port which ranges from 30,000 to 32,767. Now, since we have created the service, let's expose this so that we can access our pod from the browser. So for exposing our service, I'm using port forward command, and this -n specifies that all our resources are in default namespace. This is the name of our service, and it is getting exposed on 30,001. Let's hit enter and see what happens. We can see here that it is doing a port forward on this IP address and on this port. Let's copy this address and let's go to our browser and see what happens. And we can see here our welcome page is getting displayed from the pod. And remember, when we created our pod, we used an Nginx image. And let's go back to our terminal and see what logs we are getting. It says handling connection for 30,001. Now, one more important thing to note here is that this IP address, which is 122.0.0.7, is only getting exposed because I have added this IP address in my etc hosts file. Since I'm using a Windows laptop, I can say that if you don't add this IP address in your etc host file, you won't be able to access your application via browser. So let me show you how I added that. So as you can see here, this is my etc host file, and see I have added this IP address here, and it belongs to my Kubernetes cluster. So this is one important step which has to be done in order to access your application from browser. So from this demo, it is clear that users never talks to pod directly. They always talk to service, and services forwards the request to the pods. If you want to have a better understanding of how you can deploy your own application, create a Docker image out of it, and access it via browser, then do check out this video of mine, which is create, Dockerize and deploy application on Kubernetes. Here I have clearly explained how you can create a Docker image out of your application, deploy it onto a Kubernetes cluster, and then access your application via browser. I'll leave the link of this video into the description. Remember this one thing from this video. Pod changes, but services stays. Now, one last question. If services route traffic to pods, who creates those pods? Who restarts them when they crash? Who scales them when the traffic increases? That's what deployment do. In the next video, we will see how Kubernetes keeps your app alive. That's it for this video. I'll see you in the next one. Till then, keep learning.